Okay, 2-4, day 2, staying in this continuity section. 2-4, day 2. We're first going to talk about one-sided limits. One-sided limits. So we're going to talk about coming in to a point from the right and from the left, separately. So the way the notation is for that, you might see something like this. The limit as x approaches some c value, and then you can see a little negative here by the c. That's talking about a left-sided limit, or left side limit. So it's as you approach that c value from the left only. So you're only using your left finger to approach the c. So as you approach c from the left only, the limit's going to be the y value that you get close to. You approach. Okay. The other side of the limit obviously is the right side, and that notation looks like this. The limit as x approaches some c value, then you'll see a little plus. That means you're coming in from the right. So this is a notation for a right side limit. So as you approach c from the right, it's the y value you approach. Now, and we know that in order for the whole function to have a limit, your two fingers have to come together. In other words, the left limit and the right limit would have to have the same value. So if the limit as x approaches c from the left of a function is equal to the limit as x approaches c from the right of the same function, then the function has a limit. Okay. So if the left and right are the same value, then you've got yourself a function with a limit. So let's take a look. F of x is going to be a nice piecewise graph again. 7 minus x squared if x is less than 2, and it equals 5 minus x squared if x is greater than or equal to 2. Okay, let's sketch the graph. Then I'm going to ask you some questions. So, y equals, turn off that stat plot. Oops. Turn that off, clear that out. Let's turn this up a little bit. There. The equation has to be in parentheses, 7 minus x squared, divide by the domain, x, under test, you've got the less than 2. Second piece of the equation, in parentheses, 5 minus x squared, and then x is greater than or equal to 2. 6. See if that fits. If not, I can change it. Okay. So 2 is our breaking point on our domain. Okay, the first graph was the 7 minus x squared. So that's where I know that at 2 I'm going to have an open circle on that one because it doesn't equal 2 here. And I've got this happening. And then the other one at 2, there is a point because it equals 2. And if I put 2 in there, 5 minus 2 squared is going to be at 1. But there's a point there. And then it's coming down. Okay. So first question after the sketch is, can you tell me the limit as x approaches 2 with the little negative? So that means approaching 2 from the left. So use your left finger, you're on the left side of the graph. I need to know this y value right here where that open circle is at. If I know that, I'll know the limit, because that's the number that I'm going to get closer and closer and closer to as I approach. Well, all I've got to do is plug 2 in to the right part of this equation. If that was filled in, that would be my, well, it's still my limit, even though it's not filled in. So this was the top part of the equation, so I'm just going to plug 2 in there. It's going to give me a 4, 7 minus 4, it's at 3. So the left side limit is 3. And if you know what's coming next, what's the limit as x approaches 2, but now with a little plus sign means from the right. So now you grab your right finger and you're on this part of the graph. You approach 2 from the right. So you're coming in from the higher values of 2 and going back to the 2. And again, all you've got to do is plug the 2 back into the right part of this equation. This is the bottom branch. That was this. Plugging the 2 in there, we said that was at 1. So we've got a left side limit of 3, a right side limit of 1. What's the limit as x approaches 2 in general? That means from both the left and the right of the function. It doesn't have one because those are different. There is no limit at 2. Okay, last question. Is it continuous at 2? Well, obviously not. But again, let's remember from yesterday, you have to tell me why. What part of the 3-part calculus definition falls apart? And I think I was able to bring that up. Let me just check real quick here. See if I can impress you or not. Go split screen, media, media. I think I saved the picture right here. Oh, look at that. Now I can see the 3-part definition that's over on the right-hand side of your screen. The first part says f of c exists. F of 2 exists. It's right here. F of 2 is a 1. The limit has to exist. Well, we just said there is no limit. So is it continuous? The answer is no, because f of x has no limit. Okay, so that's just a quick review of those the 3-part continuity definitions. You have to have a point, you have to have a limit, and they have to be the same. Okay, I'm going to get rid of that and move on to our next example. I'm going to give you another piecewise function. Let's see. G of x equals 9 minus x squared if x is less than 2. And g of x equals some k times x if x is greater than or equal to 2. Your goal is to find a value for k to make g of x continuous. Okay, this isn't difficult if you think about it, because when with the piecewise graph, the reason why it's not continuous is because the two y values are separate from each other. They're at two different spots. You need to find the value that will make it have the same y value. That's your goal. So what you need to do is make the two pieces have the same y value for this problem, it's at the split in the domain here, the 2. So at x equals 2. Well, remember, each of these expressions gives you a y value if you plug the x in. So all I need to do is set these equal to each other. So I need 9 minus x squared to have the same value as k times x when x equals 2. So if I just plug the 2 in for all the x's, that leaves just the k that I can then solve for that makes that happen. So it's 9 minus 2 squared equals k times 2. This will be 9 minus 4 is a 5. This is 2k. You want to write it the proper way and just divide by 2. K equals 2.5. And now that we know the k, let's call that part A, sketch the graph. So, if you take a look, I can get rid of this. We'll go to y equals. Turn it on first. Y equals. We want 9 minus x squared. 9 minus x squared for x is less than 2. Well, that's kind of nice. That was kind of left in there from last time. Down here, whoops, I want, delete. I want, what do we find k? K is 2.5 x. And then divide by x is greater than or equal. So all I did was replace the k with the 2.5 that we found. Now when I graph this, I can see I've got part of a parabola and part of a line. And that cusp is happening at 2. So, on the 9 minus x squared, I'm going to have the open circle with this parabola going on. Then, the second part of it, the 2.5 fills in the circle, and then we've got our linear function. And that's definitely continuous. And my last question is going to be, what's the limit of g of x? For C, the limit as x approaches 2 of g of x, all I've got to do is plug 2, and I can plug it into either branch because they both should approach the same thing. So 9 minus 2 squared is 4.